Analysis of selection sort algorithm. If you remember in the last video while implementing the selection sort, I told you the selection sort algorithm has a time complexity of order of n square. Okay. Now if you look at the selection sort algorithm, the major operation is comparison, because at every step we find the minimum. For finding the minimum, the algorithm does the major operation of comparison. We need to perform comparison to find the minimum or maximum. So let's take this example which had so many steps. 5 steps were there. Okay, so this is the input array, and then after taking the input array there were 5 steps. 1 2 3 4 5. Okay, now using this array was printed, and then using this array was generated. Similarly it goes like this. Now what is the major operation? That is comparison. Okay, let's count now how many comparisons are happening in total. The next major operation is swapping. It is not the first major operation because swapping happens only less number of times compared to comparison. How many times we will do swapping? That is very simple. We will do it n minus 1 times. We will do one swap here, okay, one here, one here, one here, and 1 2 3 4, and one more we will do it in the first step here. Okay, so totally 5 swapping operations we will do. We find the minimum, swap it, and then we will find another next minimum, we will do the swapping, and then find the minimum which is 3 here, and we will swap it here, and then we will find this minimum 8, we will swap it here, and then we will find minimum here and swap it. So students, if you see here, 1 2 3 4 5 swap operations on an array of size 6. So totally we can say n minus 1 swap operations always, which is fixed in selection sort algorithm, whereas it's not fixed in bubble sort. Okay, now let's count how many comparison operation takes place starting from the given input array. Okay, when this array is given, when we find the minimum from this sub array, the whole array, we will consider this as the temporary minimum, and we will start comparing from this position. So we will compare it here 1, we will again compare it here 2 3 4, okay, and we will do one more comparison here. So first time to find the first minimum we do 5 comparison. Okay, and that is what I have mentioned it here. Okay, then in the next step this is the unsorted subarray for us. Now from this unsorted subarray we find the minimum. We will assume this as the minimum, and we will start comparing from this location. 1 2 3 4 comparisons in the second iteration. So that is what I have written it here. Okay, and it goes on like this. 3 here, because we consider this as the minimum, and we do 3 comparisons. 1 2, and here is third comparison. So that is what I have mentioned it here. 2 here, 1 here. That is what I have mentioned here and here. Okay, so students, if you have an array of size 6, the total number of comparison is 5 4 3 2 1, or you can say 1 plus 2 plus 3 plus 4 plus 5 on an array of size 6. In general, if you have an array of size n, so total comparison will be similar to this. On an array of size 6, the total comparisons were 1 plus 2 all the way up to 5. So on an array of size n, it will be the similar thing, 1 plus 2 all the way up to n minus 1. You would have understood in discrete math course that whenever we have a sum of series like this, okay, we have a formula representing that, which is n times n minus 1 by 2. Now if you multiply this, you will get a formula of n square with some more. You will get a polynomial of degree 2 when you do this multiplication. So according to the big O notation, if you have a polynomial of degree 2, you can ignore the lower order terms and you can say order of n square. Okay, so this is the reason why the time complexity of selection sort is quadratic, which is order of n square, which also aligns with what I told in the previous video, because in the previous video also I said that it's order of n square because we had 2 loops. One is for the repetition of steps of finding minimum, and the algorithm of finding minimum is again order of n. So there were 2 nested loops. Each loop had time complexity of order of n times order of n, which is order of n square, which also aligns with analysis of this algorithm. Students, please note that there is no best case like we had it in bubble sort. Bubble sort had a best case and also had a worst case separately, and best case time complexity of bubble sort was order of n, whereas there is no best case for selection sort, because even if you input an array of which is already sorted, the selection sort will do its job. Even if you have 1 2 3 4 and 5 as the input array, the selection sort, what it will do is it will find the minimum from this array and it will try to swap it and repeat the process as usual. So there is no best case or worst case for selection sort. It is always behaves in the worst case scenario.